Neil deGrasse's authoritative voice takes center stage as he delves into the intricacies of El Niño.
All I can tell you is that in the world, what we're going to find is more extremes of weather. The extremes of weather become more significant, and it'll become the new normal. So suppose in the coming decades, we have the power to manipulate La Niña, El Niño, and control the severity of the up and down of it, or possibly even flatten it entirely, separate from the ever-rising temperatures that we're creating from our own forces of climate change.
Demystifying this complex weather pattern with clarity and expertise.
It's a source of no end of misconception in our world, in civilization.
Oh, okay.
So, yeah. So it's a big one, okay?
All right.
And it's the difference between heat and temperature. They are not the same thing. All I can say is the universe is in good shape. It's Earth that has all the problems, right? So it's a frustrating time because you try to have a rational, informed conversation with someone about what is objectively true, and then people argue vociferously against it. What I'm asking is, if we had the power to do that, should we? Or is this so natural to Earth that there are elements of the continental shelves, of the oceans, that actually want this? That there's some equilibrium in that variation, long-term equilibrium, that it needs it and wants it and seeks it out. Right? So the temperature of a thing is the average kinetic energy of its vibrating molecules. Okay. All right. So you have a thing that is of a temperature. You look in close, all the molecules, or if they're atoms, it could be atomic, they're all vibrating.
The atmosphere is charged with curiosity as deGrasse's explanations illuminate the phenomenon of El Niño, making it accessible to viewers of all backgrounds.
Look, Catherine, just start. What is El Niño other than the literal Spanish translation of the boy child?
Well, you're very fortunate here because not only am I an atmospheric scientist, I am also fluent in Spanish. So I can take both on.
Okay.
So, El Niño refers to the Christ child. And the reason why this mode of natural variability in the climate system is called El Niño is because it would typically manifest in the winter around Christmas time off the coast of Peru, hence the Spanish connection.
So temperature is a macroscopic thing that you obtain from a liquid, a solid, a gas, it doesn't matter. Okay? That's temperature. Okay. So you heat it up some more, you get higher temperature. Oh, by the way, there's a range at which they vibrate. Some vibrate slowly, some vibrate quickly. It's the average that's the temperature. Let me say that another way. At a given temperature, there's the average, which is where most of them are kind of vibrating, and then there's some off at the tail. Some are vibrating slowly, some are vibrating quickly. Okay. Here's an example. Okay. Let's get water let's stick to Fahrenheit. Let's say we are 200 degrees. Room temperature water, 75 to 70 degrees. Okay, here you go. Some of those water molecules are vibrating very fast, others very slowly. Okay?
Right.
Some of them are vibrating fast enough to escape.
Right. Yes.
Okay? But it's just those only at the edge, they escape.
They're at the very top. Right.
At the very top. They'll escape, the rest are stuck.
Right.
Okay? So now they escape. This is evaporation.
Correct. Okay.
And you don't have to be boiling water to evaporate the water because the fastest moving molecules are always escaping. Okay? That's my point.
That makes sense.
Also, just while we're there, if you are a low mass atom or low mass molecule relative to high mass molecules, your low mass ones are vibrating even faster on average. You can split them up. The heavy ones are moving slowly, the light ones are moving quickly. The average of all of them, that's the temperature.
His narrative transforms into a fascinating journey, inviting society to explore the dynamics of weather patterns and their profound impact on our world.
All right, so we got the boy Jesus covered here. So now what is El Nino?
El Nino is one of the most well-known modes of natural variability in the climate system, where over time, we see these modes of natural variability where we have more heat going from the ocean into the atmosphere. That's during an El Nino, or more heat going from the atmosphere back into the ocean. That's the opposite part, La Nina. But that's not the only mode of natural variability. We also have the Pacific Decadal Oscillation. We have the North Atlantic Oscillation. But El Nino is the most well-known, and it happens every few years. So every few years, we go up into El Nino, then we go back into neutral for a year or two, and then we go down into La Nina typically, and then we go back up to neutral. And what that does is it affects our weather around the world. That's why this matters to us, because when we have all that heat coming from the ocean into the atmosphere during El Nino, the globe is a little bit hotter than average, and it also affects tropical regions predominantly, as well as we get a lot of storms along the coastal area of North America. And they've even showed, for example, that civil conflict in tropical countries tends to increase during El Nino years because of the impact of El Nino on weather and the impact of weather on people's livelihoods and the economy.
All I can tell you is that in the world, what we're going to find is more extremes of weather. Okay, when it rains, it's going to rain heavier. When it's not going to rain, it's going to rain less than it ever didn't rain before. And as these extreme, that's kind of the new normal we're going to have to grow accustomed to. And all evidence points to the fact that it is human-caused influence on the ecosystem, on the climatic system.
So cold weather will get colder, warm weather will get warmer, wet weather will get wetter.
Yeah. So the extremes, you'll start visiting the extremes. And what happens is, as the temperature rises, more moisture from the ocean gets lifted into the atmosphere. And generally, when we think of weather, we think of storms and things. And so now that when you have a storm, there's more moisture to feed that storm. There's more heating to drive the convective cells. And so the storm gets more ferocious. And, we had flooding down here in New York. By the way, this change that people are talking about, it's not one day the ocean will just sort of come in and stay there on your doorstep. No, that's not how it happens first. It happens first where there would be a storm where there'd be a tide surge. And previously the tide surge never really, maybe came over the sidewalk or the boardwalk, but that was about it. It went away. Now the tide surge makes it into the streets. And that's your first indication. These extremes are your first encounter with what will soon become the new normal.
As the nation listens, deGrasse's words become a guiding light, helping viewers navigate the complexities of climate science and meteorology.
But it comes off of Peru. Why would it affect the whole world? Why? I mean, I don't get it.
Well, it's actually a long tongue of warm water that reaches almost entirely across the Pacific. So it has a huge impact on Australia as well. And it isn't just temperature, it changes rainfall patterns. So some places during an El Nino get drier and other places get wetter. So it's a great example of what I like to call global weirding. Things just get weird. But then you superimpose this natural variability on top of the long-term warming trend caused by human emissions of heat-trapping gases. And that's when we get a year like this year.
So sound travels in waves?
Right.
So the crests and troughs, and this is a pressure wave through the air. It hits your eardrum vibrates. We interpret that as sound. So does your body too. By the way, there's certain frequencies of sound that are there's certain wavelengths of sound that are longer than what will fit in your eardrum. So your eardrum will have a hard time communicating it to your brain, but the length of the wavelength is about the size of your chest cavity. That's the low frequency, long wavelength. And so there are some sounds that you feel more than you hear. This year, 2023, where we have excessive heat in many places across the globe, in the northern hemisphere. So how long does El Nino last?
El Nino typically lasts, it's defined, first of all, as when sea surface temperature off the coast of Peru in a box, they call the Nino 3.4 box, when sea surface temperature is more than half a degree above the long-term average. And so it typically lasts for a number of months, and then it goes back down into neutral conditions. Sometimes it can last for up to a year.
Within this captivating dialogue, a tapestry of atmospheric science takes form, prompting viewers to consider the far-reaching consequences of El Niño.
So now we have climate change where the world is heating,
Right.
and you can say, okay, how much did the air, we don't want the air to go up by 2 degrees Celsius, whatever, because that could trigger other changes. Well, let's check the ocean. How much did the ocean go up? The ocean went up 1/4 of a degree, or like 1/2 a degree. And you're saying to yourself, that's not much.
Right.
Do you know how much total energy that is?
Right.
Oh my God.
That is
Oh my gosh.
that's
Okay. So Chuck, that's why when you're trying to create the energy budget of a climate system, right? There's sunlight coming in and it warms the air. Was that where all the energy goes? No. There's energy that goes into the ocean and it can hang out there lurking, all right? So you could reduce your carbon footprint and reduce the warming of the atmosphere. Then the ocean says, I got heat, I can dump into the atmosphere and I can keep doing this, even after you have corrected your behavior to protect future generations. And the balance, it's actually an imbalance at this moment. The relationship between the heat that the land retains in the atmosphere and the ocean wins every time.
Right.
Because of it's this tremendous heat reservoir.
The spotlight narrows on deGrasse, a consummate science communicator, unafraid to simplify complex topics and empower individuals with knowledge.
When was El Niño first named?
That's a great question. I'm not sure about that.
So, I mean, is there records in the 1800s, 1700s, or is it a 19th century, a 20th century invention?
It was recognized by people in Peru for some time. That's why it was already named by them by the time scientists got a hold of it. Scientists
So they just
didn't
use
name
their
it.
name. Yeah.
Oh, wow.
Yes, exactly.
Okay. It would have had to have happened after the conquistadors, because there was no Christianity until Spain arrived in South America.
Well
So that
done
would-
there. Well done, man.
Well played, right?
But they could have been calling it something else and have it renamed. You need to have an archaeologist or anthropologist on after me to talk about that.
Yeah.
The coast of Peru is very dry. And so I would assume it had a lot to do with rainfall patterns. And I'm sure that people living there noticed that every few years their rainfall patterns shifted dramatically. And they probably did have a name for it, but then you're right, they probably, whatever it was, got called El Niño after the conquistadors arrived.
Yeah.
Now, scientists have only been tracking it. We track it on a monthly basis, and we've only been tracking El Niño since the 1950s. So we have records of El Niño variability, the sea surface temperature in that area going back to the 1950s.
In this enlightening moment, Neil deGrasse serves as a beacon of scientific understanding, urging society to grasp the importance of weather patterns in our changing world.
I'm not here to debate. I'm here to offer you information. When carbon dioxide goes into the atmosphere, whatever's going on in the atmosphere, it achieves a kind of equilibrium with the oceans. The oceans are always churning. It's why the fish can breathe oxygen, because oxygen is churning at the boundary between an ocean and the air. That's why your fish tank has bubbles bubbling through it. If that bubble machine stops, we also are Finding Nemo. What happens? It gets ugly. So what happens is carbon dioxide in the atmosphere enters the ocean. The ocean has an uptake of these gases. And so it stays in sort of surface equilibrium. You add more carbon dioxide to the air, some gets absorbed so that they stay in equilibrium. If we stop all carbon dioxide production today, and the carbon dioxide begins to ebb from the atmosphere, then that will draw carbon dioxide back out of the ocean that had been dissolved over the previous years. So there will be a time delay of when you stop versus when the total carbon dioxide levels will systematically drop. Here's what happens. The lightning sound is a huge cacophony of frequencies of sound energy, okay? High frequency, low frequency. But here's the problem. High frequency doesn't travel very far. It's easily disrupted. It can easily lose its energy relative to the energy that it started with. And if high frequency sound loses its energy, it becomes lower frequency sounds. So the farther away you are from a lightning strike, the lower is the total cacophony of frequencies that reach you. The swells for storms, that's the first indication of the change in water levels. It will transform civilization as we know it. And you know who is paying attention is the military. Because if you displace entire peoples from their towns, there are islands in the South Pacific where the average elevation of the island is a few feet above sea level. So you lose these islands, and then you have a refugee problem. And this destabilizes regions, as we've known and has been demonstrated ever since the history of war and refugees.
It becomes a security issue.
A security issue, and the military knows it. It's also a financial issue. If we do nothing, sea levels rise, energy gets pumped into the oceans, that pumps energy into the atmosphere. The extremes of weather become more significant, and it'll become the new normal.